Hello, everybody. My name is Kevin Derman, and I'm the CEO of Kaskade.cloud, and it is fantastic to be with you all today to do a presentation on AWS Machine Learning ML Ops, the Swiss Army knife of ML Ops. So without further ado, let's get stuck in. I'll give you a little bit of background first on Kaskade. So what do? Well, we solve business problems using the hyperscale cloud. That's it in a nutshell, and that includes migration consulting, moving companies to the cloud, providing them with managed services, best practice alignments and policy-based governance, cost optimization, DevOps, custom integration, advanced technologies, and in particular, artificial intelligence and machine learning, which is what we are going to be talking about today. Before we get stuck into the AWS machine learning environment, take a look at why people are using AWS for machine learning and what kind of things they are actually doing on AWS.
Machine learning is going to continue to improve the lives of truck drivers.
Using computer vision and machine learning, we wanted to see if we could create an automatic analysis of autism and autism spectrum disorder.
Machine learning allows us to get very, very quickly to very complex data.
Machine learning can actually directly contribute to understanding our planet.
We can use machine learning and computer vision analysis to assess things like facial expression and attention. And so we built a set of movies that elicit these behaviors and use the camera in the device to measure the child's response.
AWS is allowing us to go through the machine learning phase together, and we can now predict future performance based on the data of the past.
The innovation that Convoy has brought is we can figure out where the right truck is for the right load anywhere in the country, and using machine learning match the right trucker at the right price to move a shipment from point A to point B.
We sail around Antarctica in 196 days with 3 vehicles. You will need to understand the risk of collision with icebergs, which can be the size of small countries. Drones are equipped with cameras. The problem being, when you're at sea, the ocean moves, the waves move, and we need to train machine learning algorithms so we can navigate it. How do we use the technology that we have developed and put it at the service of the planet?
We're embracing machine learning. We're embracing AI. We're going to truly change the game.
I like to have home time because I don't get a lot of time at home. But that's what the Convoy app does for me. It helps me be at home more.
If we can do just a small thing to change one kid, I think I would go to sleep with a smile.
Such wonderful opportunities and potential that artificial intelligence and machine learning provides for all of Now, the machine learning flow, we are all fairly familiar with. It's a process of gathering data, training your model, and obviously cleansing the data first and looking for the features that you're wanting to utilize, packaging your models that you have, validating them against your data that you have, deploying the models, and then monitoring, and then obviously retraining and coming around full circle in terms of doing that. But in this flow that we have in front of you at the moment, there's a lot that's actually missing. What about where the data is stored? What about the ETL of that data? What about, you have to transform it, you've got to cleanse the data, you've got to work with it, and then you've got to store the artifacts that you have created from your machine learning models as well. What about the compute instances that you are training your machine models on as well? And then what about the area where you're actually utilizing that information for from your machine learning, the inferences? Where are you going to be using that? Are you going to be taking that input in where a system has to make a decision on that information that's been provided, and it needs to have a follow-on reaction from that? For example, being able to switch off a heater, or be able to stop a particular machine from doing any further damage, etc. So there is so much around this, and it encompasses so many different processes and procedures, and this is why this element of ML ops actually comes in, because machine learning is not isolated on its own. It is part of this bigger system. It's part of the system from the collecting side of the information, and then also on what you're going to be doing with that particular information. So ML Ops is defined as the practice of collaboration and communication between the data science component of it and the operations professionals to help manage production, the ML or deep learning lifecycle. But it is actually even a bit more than that in its definition, because it involves the development cycle as well. It could be the application that you're developing that is using the machine learning information that's coming from it, using those inferences, and then actually doing something with it as well. So there are so many elements that are involved. And here is a great diagram that shows the machine learning aspect, how it integrates with development, and then also the ops component. So from experimenting and getting the data acquisition, finding out the business understanding, what is the business problem that we're trying to solve, doing that initial modeling. That is on the machine learning side. From the development side, it's the modeling and the testing, it's the CI/CD pipeline that you're working with, which is typical from an agile development DevOps framework that you're working with, on how you're integrating this continuous involvement of the software program that you are designing, and the continuous deployment of it when you are doing new iterations and when you are doing new development on it as well. And then very importantly is that ops side of it, the delivery of it. How are you delivering it to that organization? What is the data feedback loop? How are you monitoring the systems, and how are you monitoring the algorithms and the machine learning model that is there? What happens if there is drift, and how do you bring that back into the process, retrain your models, and then redeployment occurring in this overall system that you have? And that is essentially what ML Ops is. And AWS is really an ideal platform for this, because it has an extremely advanced system of all of these components within it. So there is no need to actually break out into other systems, because you can do the entire process from it. I'm going to give you an example over here. This is an online fraud detection reference architecture. You can clearly see there in the center over there all of the machine learning components which are residing in an elastic MapReduce cluster. And you've got all the components like Apache Ignite and Spark that are sitting over there, and those are connected through to Amazon RDS, which is a managed database service. It's got the machine learning components coming through from that, which could be a Sagemaker component as well, connecting through to the Elastic MapReduce cluster. And we have additional components coming in on the left-hand side of that as well, where you've got the corporate data center. It's bringing in data securely from that with a direct connection to it. All of this sits within a virtual private cloud. And then it's got the access, identity and access management from AWS IAM. It's got CloudWatch and CloudTrail for monitoring and for auditing of that. You've got your S3 for your storage of your artifacts. So you're starting to see here the whole ML ops aspect of it sitting in this one image. And now I think you can start understanding why it is better to actually have an ML ops environment than just worrying and focusing only on the machine learning component and just the model training, for example. And AWS gives you that total environment here as well. Here's another example which is very, very clear to see. This, in this particular example, is using Amazon Rekognition. Now, Rekognition is a artificial intelligence service that is able to take images. It can recognize individuals. It can recognize, for example, what is a car, whether the person's smiling, do the sentiment of the person. It can do so much with that. Now, those algorithms are already written, and the service is a managed service. So you're able to actually just connect to that service, get the results that you want. In this particular example, the feed is coming from an IP camera or Raspberry Pi. It's going into a bucket, which would be an S3 bucket for storage. AWS Lambda is triggering. This is a serverless function. So here you've got a function that's triggering, taking the data through to Amazon Rekognition, using that, and then Kinesis Firehose delivering a data stream back to the bucket to be processed. And then you're visualizing that data within Amazon QuickSight. So here you've got that entire flow from collection, storing the data, processing it, and then analyzing it, all within one framework, which shows you a wonderful ML ops. And then obviously you tie in the monitoring of that entire system as well. So it's no wonder that more machine learning runs on AWS than anywhere else, because it gives you this ability to actually utilize this complete system as well. And here are some wonderful names that you can see that I'm sure many of you will recognize those names. So I now want to talk about the AI stack and really give you a view here of why AWS has been chosen by so many companies as the ML platform of choice. And really it is because it gives you the ability to decide in what area you need your artificial intelligence and machine learning. So you might be a machine learning practitioner that really wants to get involved in the nuts and bolts of the algorithms. You want to design your own algorithm and bring your own algorithm to it. If you are wanting that, you are able to do that. But on the other side, end of the scale, you have things like these AI services. And this is things like the Rekognition that I was talking about. It's Lex, it's Poly, and I'll go into some of these services. But these are services that are complete. They are, for want of another word, they're almost like a black box AI service, in that you don't know what's going on the inside of it. You don't need to know what's going on the inside of it. It is a complete managed service that you are able to utilize. And you can easily add intelligence to your applications. You can add things like sentiment analysis. You can add things like image recognition through to that. Comprehend, understand documents, classify documents, etc. There's a host of services in that range as well. Then moving to the next layer, you're looking at the ML services, where you can build, train, and deploy machine learning really fast. And here you've got a whole range of algorithm choice, of pre-built algorithms that are there. You have hyperparameter tuning within your models, where you can even automate your hyperparameter tuning as well. And you can run experiments and keep tabs of them and monitor the entire process that's going through. And this is Amazon Sagemaker. Those are the services that are there. And again, in Sagemaker, you don't need to worry about the infrastructure and managing that infrastructure. It already is there for you. If you're wanting to use frameworks that you're familiar with, you can spin up those frameworks and work within those frameworks. And if you're wanting just the plain compute, but you're wanting machine learning optimized compute instances, then you can do that. So what I've shown you here is the range of machine learning infrastructure that is available, from just purely going and wanting a great powerful system right through to I just want to use the service for understanding what is in this video image that's coming through, and I want my confidence intervals on whether it says it's a car to know that it's at a 98% confidence interval, etc. To have that kind of information, you have that ability throughout. And then analytics and security completes the package. And we also have learning tools within AWS that help people to understand. For example, Deep Lens and Deep Racer gives you a feeling for the deep learning that goes through and gives you that ability to do that. So here is Sagemaker, which is that one component that I was discussing a moment ago. And that Sagemaker really gives you the ability here to do so many things. From ground truthing your data, so building and managing and training your data sets. You can use something like Mechanical Turk, which is an Amazon Web Service, where real live humans can actually go through and label your images as an example, or they can give you input on the data that you have. So they have Sagemaker Studio, which is a relatively new release for general availability, which is an integrated development environment for machine learning. So you're able to do your coding right from that particular environment. You're able to run your experiments, etc. And then within Sagemaker, there are the notebooks, which you have seen. I was talking about your Jupyter notebooks that you can spin up and do your machine learning models within it. You've got pre-built algorithms and models that you can purchase from the AWS marketplace and just spin those up. You can capture, organize, and search every step of your machine learning models through Sagemaker experiments. There's a debugger. There's automatic model tuning. So if you are not one of these people who knows precisely how to tune your hyperparameters, because it is a mixture between science and art, you can use automatic model tuning to get the best out of that particular model. And then I spoke earlier on about drift. Your models may tend to drift over time, and there's Sagemaker Model Monitor and Sagemaker Neo, which allows you to train your model and deploy it to the edge if you want to use some IoT devices, for example, and run these at the edge. And there's also Augmented AI, which gives you a human review of your model predictions. So you can see there is so much that is available over there that you can actually utilize. What this does is it shortens your machine learning cycle to development. Machine learning can be a lengthy process, and if you are having to build your models from scratch, it is going to take a long time. If you're building the algorithm, if you are building the infrastructure, if you are building the monitoring systems around that. And so what you're able to do with AWS, and what we do at Kaskade, is we shorten the time to a return on investment for any company who is engaging in an AI project. We're able to bring them real value in a far shorter time by utilizing these ready-built services. It's certainly not easy. It does make it a lot easier to do it this way, but it still isn't an easy process, and there's a lot of integration that needs to be done, and hence the work that we do. So now I'm going to speak a little bit about the AI services. These are ready-made AI services where there's no management of the infrastructure, and they are already trained models. And I want to give you some examples around these. Firstly is the recommendation engine. Many of us have purchased products from Amazon.com, and when you do that, it will tell you when you're checking out that people who bought this particular item also bought that item. And you might look at this and think, well, this is great. It's recommendation, and it's picking it up purely by analyzing what products have been bought together. But there's a lot more that's going in with that. It is actually looking at you as the individual. What have you bought in the past? And those recommendations that it's bringing back to you differ, obviously, from person to person, even with the same product. This recommendation engine has been incredibly successful. McKinsey estimates that as much as 35% of all Amazon transactions come from their recommendation engine. And Amazon makes this available to you through AWS. So you can go and you can install this recommendation engine on your e-commerce site and start using those recommendations. You could be providing recommendations for movies if you're a Netflix type company, and Netflix takes it one further, where not only does it recommend particular movies to you, but it also will show you a different image depending on the profile that it's built up for you and what it thinks you will actually like. And Domino's Pizza is another great example where they will make recommendations to people using this recommendation engine on your past history of pizzas you have bought. So this uses Amazon Personalize. That is the service that gets involved in this. And obviously it's a great ML ops framework because it integrates into your application and has storage of the data as well. Can be used in e-commerce, in retailing, etc. The next one is forecasting. So if you have sales history, if you have components that you have used in your production process, Amazon Forecast gives you a wonderful way of actually predicting going forward as to what you are going to need or what kind of sales you're going to be doing. Now, of course, during this wonderful, and I say wonderful really tongue-in-cheek with this COVID experience that we've all gone through, this throws a spanner in the works when doing forecasting. And so it's a fantastic machine learning problem to solve, is how do we utilize this blip that we've had in our data over the past 6-7 months and the changes that we've been through in forecasting going forward, but more about that at another time. Image and video analysis gets done through Rekognition, and I have explained a bit about that, but I will tell you a bit more about this as well. So here is Amazon Forecast and showing you some of that aspect. Great for financial planning, great for resource planning as well. So Rekognition itself works on facial recognition, but also on image recognition. So it could be recognizing cars, it could be recognizing trees, etc. It's a model that can be trained, but comes pre-trained as well with a host of data of being able to recognize everyday items. Facial recognition, there has been a lot of controversy around it, the legality of it, the biasness of it, etc. But what Amazon Rekognition does is it takes the metadata that's around someone's features. It will take the distance between your nose and your corner of your lips, or your eyebrows and your forehead, etc. Taking all of that metadata, so it's not really going to store the actual image of the person itself, but rather the metadata around that. Fantastic use cases for things like busy reception areas. If you're wanting to get people through your reception area really quickly, you want to recognize them, they only have to sign in once, and future visits it automatically picks them up. Time and attendance, security systems, facial sentiment correlation, and for looking for sentiment analysis in retail environments is also a great one. Amazon Comprehend is text analytics, which uses natural language processing, or NLP, to take out those insights and look at the relationship between that. There's document analysis, which is Amazon Textract. Also, these are ready-built services. And then Amazon Polly, which turns text into speech. And you might be familiar with Alexa, and Alexa actually utilizes those particular services of Amazon Polly in order to produce the information that it was. We have used these kind of services in doing social sentiment analysis. We've got Kaskade's SSA, our social sentiment analysis program, that monitors social media for the sentiments. Its users comprehend to understand that language and the context of that language, and then classifies it as positive, neutral, or negative sentiments. So you can quickly, for example, address your top negative tweets or your positive tweets as well. Chatbots, they have a service called Amazon Lex, which builds conversational interfaces and works brilliantly for contact centers or for websites, etc. Amazon Translate allows you to translate different languages, and Amazon Transcribe is a transcription one as well. Give you a quick example of these kind of services over here. I have got Alexa on my phone, and we have designed a service that can just tell people about, for example, Kaskade. Open Kaskade update.
Here's your update. Kaskade helps their customers attain competitive advantage by using advanced technologies, such as AI, machine learning, IoT, and blockchain technologies.
So there's a quick example there that shows you how you can actually utilize various of these skills, combine them together, utilizing the data store, etc., in order to build out a business skill as well. So before I sign off, I will be available for any additional questions afterwards. So if you do have any questions about any of the services that I've spoken about, please do wait. I'm going to show you another video just wrapping up some of these services. It's been great being with you, and my contact details will be displayed after this video. Thank you.
Businesses have found new ways to leverage machine learning for applications such as recommendation engines, object detection, voice assistance, fraud detection, and more. Although the use of machine learning is gaining traction, long development time, high cost, the need for agility, and high complexity are key barriers that prevent use of machine learning from becoming even more widespread. For the fastest and easiest way to get started using machine learning, AWS offers Amazon Sagemaker, a fully managed machine learning service. For more customized machine learning projects, AWS Machine Learning Infrastructure delivers a range of options to you. AWS Machine Learning Infrastructure services remove the barriers to adoption of machine learning with cost-effective, high-performance options that are agile and easy to use for beginners and experts alike. With AWS ML infrastructure, organizations can get the right amount of compute, storage, and networking performance for any use case and budget. For fast model training that reduces training time from days to minutes, EC2 P3 and P3DN instances offer the highest performance GPU training instances in the cloud. For small-scale or entry-level machine learning training, EC2 G4 instances can be a cost-effective solution. For high-performance inference, EC2 Inf1 instances with AWS-developed Inferentia custom chips deliver high throughput and low latency with the lowest cost per inference in the cloud. For GPU-based inference, EC2 G4 instances enable use of NVIDIA libraries. For inference that uses Intel AVX 512 instructions, EC2 C5 instances are a good solution. For cost-effective shared file storage of large amounts of data needed to train models, Amazon S3 is a great solution. To further increase storage performance, Amazon FSx for Lustre delivers shared file storage with high throughput and consistent low latencies. AWS was first in the cloud to offer 100 gigabits per second per instance of network bandwidth. For large-scale multi-node deployments, Elastic Fabric Adapter provides a low-latency, low-jitter channel for inter-instance communications. For highly scalable Kubernetes orchestration, you can use Amazon Elastic Kubernetes Service to efficiently run distributed training jobs. In addition, AWS offers different pricing plans to meet the needs of any organization. Business conditions constantly change, and AWS ML infrastructure can change with it. Whether it's scaling up or down as needed, choosing different ML frameworks, or changing geographic locations, AWS ML infrastructure can adapt to meet your needs. The fastest way to get started using all of this powerful machine learning infrastructure is by using Amazon Sagemaker. Sagemaker enables you to develop high-quality models by providing all of the components required for machine learning in a fully managed experience, so models get to production faster with much less effort and at lower cost. AWS provides the broadest selection of machine learning compute, networking, and storage infrastructure to meet the needs of any machine learning initiative, all with a pay-as-you-go cost model. Businesses
So I'm sure you can see why we choose AWS machine learning for Kaskade and for our clients, and working with them really gives us a great start and momentum to carry through. There's our details, and I look forward to chatting to you. Thank you.